All right, I'm going to start a whiteboard lesson on power and meridian, and I am going to talk a lot, and you're going to kind of see what one of my crazy ass lectures was like. Probably end up thinking, wow, I'm glad I was never one of his students, because I'm going to give you all kinds of information, and it's going to be up to you what you want to take and what you want to throw away, I guess. I have a little bit of a conflict here. On one side, I want you to pass the ABO. I mean, I really want you to pass the ABO. I think that's pretty obvious, otherwise I wouldn't be standing here. At the same time, I want more than that out of you. I want you to go beyond it, and not just in the philosophical way. I want you to really understand what you're doing. I could rehearse this stuff, the 30, 45, 60 rule 1,000 times with you, and you could pass the test without ever understanding what it really means. So let's take a giant step backwards, and then we'll take a step forward, and let's see if we can't make this just a little bit clearer. If I could, I'd fly each of you and put you in this room with me for a couple of days and work on this stuff, but sadly we can't do that. So we're going to do this as the next best thing, and of course, you know, you can always talk to me through email, which plenty of us do. If you were here, I think the thing I would ask you first is, if I talk about power and meridians, and let's just say I take an optical cross, okay, and just for fun, I write like this, and I have -5 at 45 degrees, and I've got -7 at 135 degrees. What I would ask you at this point is, what the hell does that mean? Okay? What is this -5? What is this -7? And if you were here, I'd let you answer that, of course, which would be nice, but you're not. So you might throw out, those are diopters, or that's power, or principal meridians, or what those are curves. Okay, and I'm going to try to get this up to the camera. It may go in and out of focus, but one of you, I know I sent one of my other samples like this to, and I'm having some more of these made up, but hopefully you can see. Let me see if I can get that into focus. I've taken this lens and I put the cross on it. Okay, just that is an optical cross on a lens. Okay, and if I turn this lens, you can see that it has a very thin edge here, and 90 degrees away, I have a thick edge. Right? That's not an optical illusion. That's not the way the lens was cut or anything. It's because this lens has two different curves on it. Okay? And in optics, all power comes from curvature. And in this particular lens, in this meridian right here, it's my thickest edge. It is my steepest curve. The machine actually went in and dug out more material here, created a steeper curve, a more powerful curve, a stronger curve. 90 degrees away, I have the thinnest edge. This is a shallower curve. It has less power. Okay? So if I took this lens and I wanted to put it on the optical cross, I would take my red thick edge and I would be putting it here, right? Because this is more powerful than that is. So my thick edge, steep curve, higher power would be there. So I have my cross, and because the lens is round, has 360 degrees, we work with 180. If I put a line across here, everything would line up absolutely perfect. With this, when I went to block it, I went to edge it, went to put it in a frame, if I put a block on this and I hold it in place so it can't rotate anymore, when I cut it, I'd have my -7 at 135, and by default, I'd have my -5 at 45 degrees. Now, those are my principal meridians. That's what the optical cross represents. Now, if I come back over and we take a look at this lens again, take it like this, I have my thickest point, I have my thinnest point. It will never be thicker, it will never be more powerful than this spot right here. It will never be thinner nor less powerful than this spot right here. And every single point and degree between these two spots on the lens, the thinnest and the thickest, has a decreasing or increasing amount of power towards the strongest or towards the weakest point on the lens. So I want you to think about that. If you need to rewind, watch it again. Rewind it, watch it again. If you can get your hand on a lens like this, I think it helps. I've always found it has. It helps me. And again, I've got some more coming, so if you need one, let me know, and I could probably work something up for you. So you're not thinking necessarily exactly numbers. You're not thinking diopter. You're not thinking primaries. You're thinking of curves, and curves being power, because this is actually a lens. This is not a whiteboard. This isn't a drawing. This isn't an optical cross. These aren't black lines. This is a lens. That's what you're trying to picture. That's what you're trying to draw. So many people seem to struggle with the optical cross, and we're not going to go there in this particular whiteboard lesson. We'll get to that in the next one. But remember that the distance you travel, all of those other spots on the lens, as I said, it's building up, building down. The distance between these two, in this case, -2, okay, is your cylinder value. And I was thinking about this last night because this stuff keeps me up at night. I really worry that some of you don't know how to use the lens meter yet. And personally, you shouldn't really be able to pass the ABO if you don't know how to use the lens meter. And if learning that this is exactly how the lens meter works. So if you think about the lens meter drum and the optical cross and power, it's all the same thing because you're basically reading the same stuff. So I would encourage you, if you don't know how, learn the lens meter, and this stuff should come into focus a little bit easier for you. On the ABO, you are only going to have questions pertaining to the 30, 45, and 60 rule. That's it. You're not going to have anything else. There's not going to be a powers and oblique meridians formula calculator on there. It's not going to happen. So I'm going to have my cheat sheet up here because I don't have to memorize this stuff because I'm old and I already have my ABO. And this tells me that at 30 degrees away from my given axis, I find 25% of my cylinder power. At 45 degrees away from my given axis, I find 50% of my cylinder power. And at 60 degrees away from my given axis, I find 75%. Right. So we're going to work all three of these scenarios. We're going to work a 30, a 45, and a 60. Right. And again, I'm using cheat sheets. No sense me starting this whole thing over from scratch. Let's take -5, -2, my favorite. Okay. We're not going to draw anything. We're just going to take -5, -2, and we gave it an axis of 70. Okay. You may see this exactly like this on the ABO. And they're going to ask a question. And the question is going to be worded like this. And this is super, super important. What is the, highlight that. Okay, total. Okay, total power. That is the key. This is what they're asking for. They're not asking for degrees. They're not asking for percent. They're not asking for anything else. What is the total power at this lens at 40 degrees? Okay. That's how it's going to be worded. Now, what you need to do is figure that out. So you need to know what's at 40. You have 70. So 70 degrees minus 40 degrees, by golly, what a surprise, huh? Is 30 degrees away. So what this is really asking you is, what is the power 30 degrees away from 70? And this is how it's going to be worded, because it has to be. What does our rule tell us? Our rule tells us that we're going to find 25% of our cylinder power 30 degrees away from there. What is our cylinder power? Cylinder power is minus 2. So we're going to bring our minus 2 down here. Minus 2 times 25% is minus 2 times 0.25. 2 calculator, 2 minus sign times 0.25 is minus 0.50. All right, good. See, use calculator. Why not? And this is the hot button. All right, this is a problem area. Okay, this is where everybody makes a mistake. Everybody thinks, oh, that's it. Oh my God, I just did math. I'm done. You're not done. Okay, you still have more to go. Because you want total power, and your total power is your sphere plus this. So now I have to take my minus 5 plus my minus 50 to get my total power of minus 550. This is your answer. This is what you're after. That would be on A, B, C, or D as a multiple choice answer. I drew this out on an optical cross, so to speak, or a powers and meridian drawing, but we're not even going to go there. There'd be no reason to do it. Your answer's there. The answer will be in the A, B, C, D multiple choice. Check the box, move on. So I'll leave that up there for just a second if you need to go back. But now we're going to do 45 degrees. Let's see here. All right. This time we went with a minus 475 minus 350 in an axis of 166 degrees. Question is, what is the, here's your keywords, total power, okay, key, that's okay, at 121. 166 degrees minus 121 degrees. What a surprise. It's 45 degrees difference. What does our rule tell us? Our rule tells us that at 45 degrees away from my given axis, I'm going to find half or 50% of my cylinder value. What is my cylinder value? My cylinder value is right here. I can bring this down to here. Minus 350. What is 50% of minus 350? I multiply that times 0.50. And I get my calculator out. I got 3.50 minus times 0.5 is minus 175. Minus 1.75. Okay. All right, red flag moment. Okay, everybody's thinking, oh my God, I just used a calculator, I'm done, I got it, there's my answer, 175. No, okay, because we're looking for total power. Total power is this plus this, minus 475 plus minus 175 gives us 75 minus plus 1. 650 minus 650. That would be your answer. Underneath this thing, you'd have A, B, C, D, multiple choice. C would be minus 650. You'd circle B, and you'd move on, and you'd have the question right. Again, I could draw this. There'd be no point to it. It would probably only be more confusing. If it would help you, and it may or may not, flat transposition would tell you that 90 degrees away, you'd have 825 as a sphere. And that's clearly between your two principal meridians, so that would kind of be a little self-check as well, but we'll leave that alone. All right, let's look at 60 degrees away. See what we use for this one. For this one, I used minus 2, minus 1 at axis 55. What is total power at 115 degrees. 115 degrees minus 55 degrees just happens to be, son of a gun, 60 degrees. What is my rule? 60 degrees away from my given axis, I'll find 75% of my cylinder value. 75% of cylinder value. What is my cylinder value? My cylinder value is minus 1. Take my minus 1 times 0.75. 75, look at that, I'll be darned. Minus 0.75. And by now you're getting the hang of this and you're thinking, I'm not done. Red flag item, okay, not finished, because I want my total power. So now I have to take my sphere, let's highlight that. And we've got a minus 2 plus minus 75, total minus 2.75. There's my answer. I'll have A, B, C, D, minus 275. I'll give you a plus 275. I would sneak in a nice minus 75 because somebody's going to make that mistake. And you're going to circle A, and you're going to get the problem right. there's 30, 45, and 60-degree rule for solving for ABO problems. Next, we'll look at the percent rules in the chart for in between, but don't worry about that maybe until you take the ABO, pass it, and then come back to it and look at it again. Hopefully that helps a little bit with that part, and we'll move on from there. So you guys let me know. This helps, doesn't, pass it along. Tell me what works, what didn't, slow down, shut up, whatever. Let me know. Thanks.